We are.
That's fine. Who is it tracking?
One started. Yes. Yes, one. Also, I can. I'm just with the third kid. Okay, they consider this portion. I've never.
Yeah, I can.
It said.
So once y'all are finished getting food, we're gonna and scanning that QR code, we're gonna get started. Scanning the QR code and filling out the attendance form does get us funding for more pizza. So it's a win-win. They have not responded to the request, like the budget, but so. Yeah, they probably looking for it. Yeah, that's why. Yeah. Okay. Yeah, that's fine. That's not that I feel like I should get full. I could definitely like know about you guys on the workshop. Yeah. I'll order some. Yeah. So if you want to finish scanning that QR code, we're gonna get started now. So let's get started. Thank you all for coming. This is an amazing turnout. So we have a lot planned for the next few days. So first off, Swamp Packs is starting on Friday. Check-in is from 6 p.m. to 7 p.m. At 7 p.m., we're going to come back to this room and SSD is going to meet up. And normally, like what we did last year when it was virtual, is we just kind of hung out and we all like coded together, and the groups from SSD sort of just hung out. We assume like this room is available, but you know, we can always, we'll just figure out what works best. But this room is where we plan on meeting for Swamp Packs at 7 p.m. on Friday. And then the next day, Saturday, we have planned to give a workshop intro to Git. That was what they asked us to do for the hackathon. So they have us scheduled at Saturday at 6:15. That's through their own, like, I guess, Zoom thing called Hopin. But then we'll also still be in this room, A101, and we'll also have like sort of like an in-person workshop too. Because again, Swamp Packs is virtual, but SSD likes to do things in person. And then of course, we'll have our normal Tuesday meeting that's going to follow that Saturday. And that's going to kind of follow up what we covered during the Swamp Packs. So that'll just be like a more advanced, Git stuff. So like intro to Git will be like more push pull, like for your personal projects and stuff like that. Advanced Git will more or less cover stuff that you're going to use in the industry when you have to work in big teams of and on big projects like that. So yeah, without further ado, I'm going to hand it off to Jonas, and we're going to get started with the Go workshop.
Awesome. Thank you, Trevor. Hi, guys. Thanks for coming out. I'm Jonas. I'm the Trevor here. And today, me and Michael, our VP, are going to be giving a quick crash course on Go. We're going to kind of run through all the main features of the language, syntax, how it's different from other languages. And Michael will also be giving a short demo at the end, doing things like concurrency, interact with APIs, and some other things. So, first things first, if you've never heard of Go before, it is a statically typed compiled language. That means that whenever you want to run your Go program, you actually have to compile it to a binary in exe. And it's statically typed, meaning it's not like Python or JavaScript where you don't have to specify type for your variables. Go has become very popular in the industry lately, specifically for backend stuff. Mainly any kind of REST API, various microservices, anything involving cloud infrastructure or networking. They've seen a lot of growth in the Go space in the last few years. And if you're looking for any kind of position as a backend role or as a backend intern, having knowledge of Go could really put you ahead of the competition, because it's not something that I see covered in college classes that much at all until this semester. And just wondering, by show of hands, who is here from Intro to Software Engineering? Okay, awesome. Yeah, now who here has experience with Go previously? Okay, so we can fix that today. Try to give you some resources to get started with the language. I would not say that Go is quite a beginner-friendly language. You'll see that some of the syntax and the way it handles things are different from other more common languages you might know, like C++ or Java. If let's say you're programming one and you're not too familiar with the stuff yet, feel free to raise hands, ask questions. I'll also be down to talk with you about whatever concepts you want to understand after the presentation. So let's go ahead and get started. So first things first, as always, we'll start with a simple hello world. So there's three main things that we have here. Text disappeared. So the first thing we have is a code package, the code will import from other files, and a main function. So I'll go ahead and start by talking about the main function. It's kind of standard. You see that in a lot of languages. This is what a basic function looks like in Golang, and this is what a print statement looks like in Golang. Now, the two things on top of that, we have a package and an import. So in Golang, all of your code has to be a part of a unit that we call a package, and we're going to explain that more at the end of the presentation. For now, the examples we have, if you're following along, you can do it in just one main file and run them, which is extremely important. It's how we organize our code in this language. This right here is an import statement, again, like an import in Java or Python, or like an include statement in C or C++. Pretty simple. And also one more thing, if okay, looks like we're missing from the side. If you'd like to follow along, we don't have a GitHub or anything for this, but you can go to go.dev/play, and it'll take you to an online Go editor. So if you want to test out any of these concepts for yourself or see how anything's work, you can do that. You can also just go to Go Playground, and it'll take you right there. So first things first, the most simple thing you can do in language, declare a variable. So there's three ways you can declare a variable and go. First things first is initialize. It's just var type. Initialize it, you just set an equal sign to the right there. So it's type difference. So what that means is if you assign a value as soon as you declare your variable, the compiler can automatically assume what that type is. Now, this does not mean that it's dynamically typed. Whatever you assign this to at first, that is the type you set it to. So if I set x equal to 7 now, and then I try to reassign x to a string later, that's going to be an error, right? And the last way we have to declare a variable is a shorthand initializer. Here we just do a variable name equals and then the value. And as you can see, this is the shortest, cleanest, and most common way to initialize variables. In the industry, this is what you'll see almost all the time. The main catch with this is that it can only be used inside of functions. So any code you have outside a function, you will have to use a var. Aside from that, that's how we declare a function in Go. Now you can declare multiple variables on the same line. Now, if you want to declare a variable in an uninitialized way, you can also do that. If you specify a type, they have to be the same. So as we can see here with this first example, I've specified that then so that's all it would have to be. Now, it is possible to declare multiple variables with different types on the same line, but you just can't specify a type, right? So we will just use type reference here. So here we have a number and a string. We set that equal to 1 and hello respectively. And again, the shorthand initializer is a cleaner, more common way to do this sort of thing. And while we're on the topic of variables, a very important note here, that might drive you crazy about this language when you start working with it. Go does not allow any unused variables at all. It also does not allow any unused imports, meaning if you have a variable and let's say you have some function afterwards that use it and then you delete that and then you forget to delete that variable too, the program will not compile or run at all. So this is, if you like it stylistically, you can say it's good for making sure you don't have any unused junk in your code. But that's just something you need to keep in mind. So now we have our primitive types in Go. Again, you've probably seen most of these before. So we have our booleans, it's just a simple true or false. Strings, they store sequences of characters. So if you want to like spell words and stuff, you can do that with strings. We have signed integers, unsigned integers. Where you want pointer type, we typically don't declare this type specifically. There's a separate notation for pointers in this language, but it's the same size as a unsigned integer or signed integer. We also have float 32 and float 64 for decimals. We also have a byte type for representing individual bytes. That's just an 8-bit unsigned integer. If you kind of go back to how bytes work, a byte is 8 bits, an 8-bit integer is 8 bits, so that's all that is. And then we have something called a ring. Now, this one is also an alias. This is just a 32-bit integer under the hood. And we use this to represent Unicode characters. Now, if you've ever used C or C++ where you've used a character type to represent a single letter, for example, we use a ring instead in Go. The reason why we use a ring is because we use something called Unicode instead of ASCII. All that means is just allows us to represent more characters in our strings. I'm not going to go too much into detail about kind of low-level details of how that works, but again, if you have any questions about that, I'll be glad to talk with you about it later. We have some more integer types. You might have noticed in the previous slide that for floats, we have to specify if we want them to be 32 bits or 64 bits. We can also do the same things with integers. So we have 8, 16, 32, and 64 bits for both signed and unsigned. Now, the unsigned integer and pointer types will automatically be either 32 or 64 bits, depending on your systems. Just about like every computer nowadays is 64-bit. So that's kind of standard, but if you're in a situation where you really need to be sure that you're using an exact number, you can use any of these types here. So now zero values. Now, this is just what Go assigns to a variable that's uninitialized, right? So like we mentioned, you can declare a variable without assigning anything to it yet. In other languages like C++ or Java, that could be what we call a garbage value, right? So if you don't initialize it, it could be anything you don't know. Go is different, as in if you declare a variable but you don't assign it, you will get one of these values every single time. So for any kind of number type, it will be 0. For any kind of Boolean, it will be false. For a string, it will just be an empty string. And then for structs, it will be nil. And if you're unfamiliar with structs, we'll get to that in a few slides. You can kind of think of nil as null in other languages. So now we're typecasting. This is one thing that's handled a bit differently in Go than other languages. In some other languages, if we're casting, for example, one number type to another number type, it's often just done automatically, right? So let's say if we had float and we wanted to assign that to an int in like C++, for example, you could just put that on one line without specifying anything, and it shouldn't break your code, although you might lose some precision. In Go, on the other hand, if the types are between two variables are different at all, and you want to put the value from one into another, you have to specify that. This is true even if you have the same type of information, but with a different precision. So, for example, on the bottom right here, we're casting an 8-bit integer to a 64-bit integer. Now they're both integers, right? And any 8-bit integer is a valid 64-bit integer. But Go says we have to explicitly convert that, or the compiler is going to yell at us. So again, the syntax for that is just the name of the type you want to convert it to, and then in parentheses, you put the original value. Now, the second major building block of any language, functions. So we declare functions in Go with the func keyword, and we put our types at the end of the function after the elements. If you have a void function, you just don't add a type at the end. And for our arguments here, we do kind of in reverse in other languages. We say the variable first, and then we put the variable's type afterward. So in other languages, it's typically reversed. If you want to look at TypeScript, it also does it this way, but just a small syntax detail. Now, one kind of cool thing about Golang is that if you have more than one parameter and they're of the same type, you only have to put the type once, right? So as you can see, I've got two integers as my input here. Instead of saying x int, y int, I can just do x, y int, right? So that kind of helps for readability and keeping the code concise. Another thing about Golang that's not typically seen in other languages is that functions can return multiple results, and they also don't have to be the same type, right? So for this very basic example here, we just have a function that returns two hard-coded numbers, and when we store them in our variables, we do a comma b. So basically, just for each variable that's being returned to, you just put a comma in between it. And this is probably the most important thing we've seen so far. You will notice when you're working with any kind of external library that professional Go code tends to use this a lot. So it's just kind of good to get used to that. It will throw an error if you try to call a function that has two returns, but you only assign it to one variable. So do keep that in mind. Now, one thing you might be wondering is, okay, well, if in Go a function can return multiple results, right? I only need one of them. Wouldn't that put us at risk for a compiler error since we cannot have any unused variables in Go? Right, that would. And the way we handle that is by using an underscore. So this is the exact same function as before, but this time we're only printing A to screen, meaning that second output value is unused. So the way we get around that is we just put an underscore on where that second return value would have been. Now, for if else statements, this doesn't look too different from other languages. The main difference here is that you don't need to have parentheses around the condition. However, you do need braces. I do know in other languages, for example, if you're only doing like a one-line if statement, you might not need a brace afterwards. They are required in Go, but parentheses are not. One thing also is if you know what ternary operators are, Go doesn't have them, unfortunately. And for those who are curious, a ternary operator is just like a one-line if-else statement. And that's really all there is to the intro for that.
Else if or else statements, they have to be on the same line as the closing curly bracket from the if statement prior. You can't do it like the line below in other languages.
Went over that. Thank you. The thing about if statements and Golang that are a little bit more unique are short statements. Basically, what we can do is have a short one-line statement that executes before any if-else chain, and any variables used in that short statement will be accessible for the rest of the if-else chain. So this is very useful for any situations where you want to get some kind of value, but you don't want it to be in scope for like the rest of your function. So for example, if we're comparing an X from a function called getNum, you only have access to that X for the duration of this if-else chain, meaning once I pass this last curly brace, I can't use X anymore. This could be, again, really useful for any kind of throwaway values where you just need to use it short, be done with it, and you don't want to have it in memory. Now, for loops. Just like with if statements, we don't need parentheses in Golang. We do need braces, however. And this is pretty similar to just a normal for loop in other languages. Official sounding names, the initializer, condition, post statement. I'm pretty sure a lot of us don't even remember it, so I'm just going to call it the front and end part. Those are optional, right? You can do a for loop without the initial value or the post statement here to increment it. Meaning that if you just have the condition, right, the condition that tells us when the loop ends, it's basically a while loop. And again, this brings us to another very important concept. Golang does not have a while keyword. A while loop in Golang is a for loop that just has a condition, right? So if you ever see anything that just says for and then some kind of condition that evaluates the true or false, then it is a while loop, right? And this example we have right here is an infinite loop. Please don't do that in code. Another important concept, arrays and slices. So the official array type in Golang is fixed size, meaning that we have to specify how big it's going to be when we declare it, and we cannot add or remove any more space from it later. Now, anyone who's ever worked with arrays of that type know that's annoying. Many times in an array, you'll often have to add an element to the end of it, do a similar operation. So we have slices instead for dynamically sized arrays, right? And those work basically similarly to vectors in C++ or array lists in Java, or even just lists in Python. And we declare it with the make keyword here. And as you can see, the syntax for this is, in my opinion, a little clunky. But it's just array slice name, colon equals make, and then the type of your slice, and then the capacity. For reference, a few useful slice methods. Again, if you need to refer to this later, because I don't expect that anyone here would learn a whole programming language from one talk. We will be uploading the slides and a video later, so hopefully we can come back here if you need to look back at this. Again, the make keyword is how we create a new slice. The append keyword is how we add a new element to the end of it. So this line here, append slice 4, it takes that it takes that slice that we just made and adds 4 to the end of it. Now, we can also do resizing operations with the slice operator here. If you've ever worked with slices in Python or MATLAB, this works exactly the same way. So what this is saying is that I'm going to set our slice equal to the same size, but we're only going to keep indexes 1 through 3. And I have a small error here. I shouldn't have that colon. If you're assigning something to a variable that's already been assigned, you don't do colon equals, you just do equals. This line here is correct. And for removing the last element, there's not a dedicated like pop and back function, but you just take a slice that includes everything except the last element, right? So here we're saying slice, the colon, there's nothing before the colon, meaning that we keep everything up until this point, and we will stop it at the element before the last one. And then finally, given the length, it's exactly like you would in Python. It's len parentheses a slice. Okay, structs. Now, you might be familiar with these if you've ever done any like C programming. So structs are similar to objects in other languages in that you can group multiple variables of different sizes together. So the zero value of a struct is nil. Like we mentioned earlier, if you have any kind of empty struct or a struct that you don't initialize, it will be nil. And again, that's just like null in other languages. Here we have an example of structs right here. This is very simple. We want a type that would represent a student in school, right? Just have some basic information, their name, their age, and their GPA. And we can go ahead and create a struct object to store that together instead of keeping them separately. And you might notice the syntax for this is just like an object, you do a dot to get whatever comes after. So you do a dot to access whatever variables are inside a struct, and you can assign them like this. Now, structs also have something called a receiver function. This is also similar to objects. It's like a class member function. The big difference with these are you don't define them inside of the struct. So in a class in other languages, for example, you would have the definition for this function inside your class. Here it's separated from the struct, and I'll explain why on the next slide. Basically, the way the syntax for this is you do func, and then in parentheses, the name of your struct and its type, and then everything else is like a normal function declaration. So here we have a simple function to print the name of a student. So we declare our student variable here. We call dot print name, and it accesses that kind of like a getter from the language. Now, you might notice that in effect, using a receiver function is kind of like just passing in the struct, excuse me, as a normal argument to a function. You can do that for a lot of cases, and most of the time it will do the same thing. However, there is one concept called pointer indirection that you can't use if you just pass a struct in as an argument. We'll talk about that later. Now, a couple slides ago, I mentioned that structs and classes are not the exact same thing, right? And y'all might be thinking, okay, we can group variables together and kind of use them as like our own custom reusable types. And we can assign our own functions to each one of these structs. So how is it not an object, right? How is this any different from like a class in Java or Python? The number one thing is that it doesn't support any of the more complicated object-oriented programming tasks. So things like inheritance, polymorphism, you can't do any of that in Golang. That's why I kind of say that structs in Go are more similar to structs in C. Only difference is that you can attach functions to them. Now, some people might say that being able to attach custom functions to them does make them objects. I'm not an object-oriented programming expert. If y'all want to have a debate on that, go ahead. But the official Go documentation says that structs are not classes. So for the purposes of this workshop, I'm going to say structs and classes are two different things. Now, pointers. So first things first, if you have taken programming 2 before, don't be scared because in Go, you do not do any of the complicated memory management stuff that you would in C or C++. It is garbage collected, so you will not be doing anything like allocating memory, deallocating it, worrying about those types of memory leaks. Just basically store the memory locations of things, and that is it. And now for those of you who haven't gotten a programming to yet, a pointer is just a variable that stores the memory address of another variable, right? So you could kind of think of it as the address for a person on the street. Let's say I am Jonas and I live at 123 Main Street. The value of a variable would be like Jonas, me, and then the pointer would be 123 Main Street, right? It's telling the computer exactly where that variable is located and where the hardware can find it. So now the basic syntax for a pointer is almost identical to C and C++. So the asterisk declares a pointer. You typically won't use it on a var statement like this just because of the shorthand declaration that is best practice. And putting an and somewhere before a variable will give you that variable's memory address. So it's very similar to C++. Now, one really big benefit and really kind of the only reason why pointers are really important in Go is passing in the functions. So Go is a pass by value language. And what that means is if you have some variable and you pass it into a function, it is going to pass a copy of that entire variable into the function. Now, this has two main really big repercussions. Number one is since what you're getting is a copy, if you make any changes to that input variable from within the function, it will not change the original value. And sometimes we want that to happen. Sometimes we do want to change the original value. Now, other languages will allow you to do this automatically for certain types. Go does not if you just pass in a variable normally. So using a pointer allows us to modify the original variable where an input came from. Now, the other big thing is that we're passing by value, right? If you're copying the entire struct, that could be a really big problem if you're working with a really big struct that holds a lot of data, right? So passing by pointer allows us to just basically, instead of copying, let's say, some big struct that has like 200 fields in it, 200 variables or something, we just tell the function, oh, look over here at the struct we already made. So yeah, we covered that. And this is an example of what it looks like. So here, kind of similar with our student example, we're passing a pointer to our function. Here, we declare our student type, and then we declare a pointer to our student type. Again, the syntax for this is nearly identical to C++. Only different is that the pointer symbol is on the left side of the type instead of the right side. And then finally, we call the print name function, but this time we pass by pointer, so this function will accept a pointer instead. And that's really all there is to it. Now, I mentioned this a few slides ago. Probably, in my opinion, one of the most confusing aspects of Go, and that's pointer indirection. So first things first, this only works on receiver functions. Now, I mentioned a few slides ago that you could attach certain functions to structs called receiver functions, and it's basically just like making a function for an object in another language. And I asked, how is it any different from just passing a struct itself in as a parameter to the function instead of doing this extra stuff here? The reason why is this allows you to use pointer indirection. And all that means is if your receiver is expecting a pointer as an argument, right? But you end up passing a value instead, your function will still work properly. Now, if you were to do this with a normal function, that would show an error, right? Normally, you can't pass a value to a function that wants a pointer because the types don't match, right? Same way in C and C++. However, if you use a receiver function, this will allow you to get around that. So the way it will work is we'll just use a memory address of the value you put in. So it will get the address of that value automatically, and it will still behave as if you pass it by pointer. So meaning the original value is still going to be modified here, which again is really great for those really big structures where we don't want to copy a whole bunch of data, just to like not use it again. Now, pointer indirection also works in the other direction. If the receiver wants a value as a type here, so as you can see, we have no asterisk, so it's asking for a copy of the struct. If you pass a pointer into that, it will still work. So as we can see here, we declare a pointer right here, and then we call the receiver function on this. This will still work, right? Now, the catch is that this time it will work as if you pass by value, meaning that even though you call this from a pointer, any modifications you do to the struct inside of this function is not going to change the original struct, right? And that's because the input is designed to be passed by value, meaning that it's only going to make a copy of this even if you gave it a pointer already. Now, is there any confusion about that? I know this topic, compared to anything else, was very confusing for me when I first won game. Okay, and again, I'll be happy. Oh yeah.
About the point about how you pass the variables. So like in the main function, when you say that student equals student and then you put the name, age, and GPA, how can you see which value is what type of variable? Because like if age and GPA were both going to be integers, like is it, do we look like at the student class or the struct and say like whichever comes first is going to be like if the age comes first in the student struct, and you see like the curly brackets for the student in the main, and you see 21 quotes in front of 3.2, so 21 is going to be age, or how does it work?
Yeah, so declaring a struct like this, you will just do it in the same order that it's declared in the struct. There is also a separate notation that you can use where you can specify the name of the struct and only declare some of the variables in there at a time. In that case, anything that you left uninitialized will just automatically be set to that variable 0 value. Let's see, and then I'm sorry, what was the second part of the question? Okay. Yeah, Brian.
This receiver function here, so it receives S, which is a student, not a student pointer. Does that mean that this receiver function cannot modify this object?
Exactly, yeah. So since the function itself is passed by value, even if you call a pointer on it, right, it's just going to take the value of that pointer and copy it, right? So yeah, you're exactly right. Alex? Just for the record, I have my internship, haven't done too much on it lately, but typically yes, you would just use the asterisk there. Angle.
Is there like any special notation if you're like in the receiver function, if you're passing in like a student pointer, do you need to like depointerize it to access its fields, or does it automatically do it for you?
Yeah, that's the great thing about pointer indirection. You don't. If again, what determines whether it is passed by value or passed by pointer will be the type of the input for the receiver. So again, this one here is passed by value. If we come back to our previous slide here, this one is passed by reference, meaning we can modify the original values. So that's a great thing. And again, if you just do this with a normal function where you pass the student in as a normal argument, then you will have to dereference it normally. right? But again, by using receivers, we don't have to worry about that. No. Extending, you mean like, yes, actually, yeah, so that is a great point you brought up. You can basically define your own functions that work on any type, right? So while we have our own receiver here that works with our own student struct, you could do this on any type you get, right? So if you had some kind of struct that is coming from an external library and you didn't write it yourself, you can make your own functions that work on that struct yourself. And that's really cool because in other languages where you're working with classes, if you're using an external library, you can't really do that unless you modify the original class itself. And typically changing external libraries is not good practice. So that's a great point. Another thing too is you can also use receiver functions on primitive types. So you can use an integer here instead, and if you have an integer variable, you could call your own functions that will work on those. So yeah, great question. Do we have any more? It still works away with pass by copy and pass by value. Now, of course, if it's something like an integer, then probably wouldn't matter much since like an integer and a pointer are the same size. Maybe if you have like a really long string, then passing it by pointer could work. And then there's also the issue with like if you want to modify the original variable, then you have to pass by pointer, right? Yeah, great question. Okay, if we don't have any more, we'll go ahead and move on. Another thing that's really kind of unique that goes away, we handle arrows. So Go does not have try catch blocks. Instead, it forces you to handle arrows in a way that's really explicit. So typically you'll return them as a second result. Again, when you start working with external libraries, you'll see it's very common that if you call a function, it will have two arguments. The first argument is going to be whatever that result is going to be for the function. And the second argument will be an error variable, right? And typically the way you work with that is you call the function and then you check the error value. Now, if it's not nil, and remember nil is basically a null in this language. If it's not nil, that means there was some kind of error and you need to handle that, right? So in this function here, we've got an example where we take a square root. So here as our input, we just have the number that we want to take the root of, and then our outputs are a float and an error. So basically, this just throws an error here if our input is less than 0. If y'all remember from our math classes, we can't take the square root of a negative number. So in that case, we would return the 0 value for our original type. Now, since float is a primitive, again, we don't use nil for that. We would use 0. If you're using a struct as an input, you can just return nil for that, and then return the error afterwards. Now, for here, I'm also realizing there's a mistake. For the return, if everything went well, we would put our value first, and then we would put a comma here, and then the word nil. Again, there was no error. Mistake on for omitting that. You can have for this return here, how we just return the first result, comma, the second result. And we come here and check that. But this, if error does not equal no statement, you will see it many, many times in your code and going. That's also probably one of the biggest criticisms of this language that I've heard. It kind of makes your code a lot longer because you have to put these kind of statements everywhere. But I think it's pretty good if you want to learn to handle your errors more explicitly. So Yeah, this would just be a compiler error. This was just a mistake on my part. You would need to put the result here and then comma nil. So, and that's true for any function with multiple returns, with multiple return values. If it's got 2 return values, I have to return 2 things. If it's got 3, I got to return 3 things, and so on. Right. So, short answer is no. This is not like Java where you can set like literally anything to be nil. Now if it's any kind of struct, right? Any struct can be nil, but specifically for those primitive types, like we mentioned, integers, floats, strings, booleans, those can't be nil, and you would want to return the 0 value instead, which again, 0 for numbers, empty string for strings, and false for booleans. It's not, and I actually meant to include the import statement there. Sorry again on that, but there it's part of the Golang standard library. You just put import in quotes errors, and that will return the entire errors package for you. Just a side note on that in general, the Golang has a really good standard library that handles a lot of stuff. Has built-in error handling, built-in unit testing, built-in networking stuff. So if you're working with anything on Go, we're actually going to talk about packages and stuff on the next slide, but in general, if you have a pretty basic thing that you want to do, check the standard library first because it really has a lot of stuff built right into the language already. All right, so now packages. So packages are extremely important for how we organize our code in Go. Really, if you're not using packages, you can't really do anything more than a single source file. And they're actually required, right? So if you've ever ran Go code before, you'll know that the file where your main function is has to be package main. So it's required that that's where your program starts. If you're not familiar with what a package is, it's just a collection of related source files. So one way to think of this here is this folder, right? So let's say we have a whole bunch of code for a program that does certain things. Now I have 4 source files here called algebra, arithmetic, geometry, and stuff for handling random numbers. So what do all 4 of these have in common? They all handle math stuff, right? So to kind of help organize our code and make sure we don't have just a million files everywhere in our folder, we can separate them into packages, right? And that kind of allows us to organize our code into separate units that do relatively independent things. And again, that kind of just comes back into having clean, maintainable software design, something we emphasize here every week. So when we're actually making a package, it must go into its own separate folder, right? So the main package, you can just have that all the way at the root of your project. This example here, everything we want in the math package would go in a lower folder, right? And the folder, as for the folder name, it is best practice to name it the same thing as your package. You can give your folder a different name, but please don't. That's harms readability. It can often confuse anyone else who has to work on the code. And now we have modules, so going one level up from packages. Now, first things first, the term modules is kind of used differently in different languages. Like I know in JavaScript it has its own meaning. Specifically in Go, a module is a collection of one or more packages, right? So again, we kind of have this hierarchy. We have just a single source file, and then a package contains files of code in them, and then a module contains one or more packages, right? So a module is used for managing and tracking our packages. This is how we will learn to use external libraries. This is how we will kind of manage our whole project structure. And we usually only have one per project. It's managed by a file called go.mod at your project's root. If you ever done JavaScript development, this is basically the exact same thing as a package JSON. If we come to the next slide here, this is an example of what a Go mod might look like. Here we just have the module name, again, which will usually just be the name of your project, the version of Go that your project is using, and then under here in this require thing, we have a list of all of the external libraries that your project uses. So we come back right here, right? How do we go? Did I have a question? Oh, yeah. So setup, right? How do we go and get this started? So basically, at the root of a project folder, we want to go and type in go mod init and then our project name, right? So what this is going to do is it's automatically going to create that go mod file for us. Now, for the project name, if you're running some kind of project that's just only going to be used locally for your own purposes, then you can just give it the name of your project. However, if you are writing a library that other developers are going to use, you are going to need to name it where you're going to name it the repository where it is hosted, right? Basically, the way libraries work in Go is whenever you load them, that go.mod file goes to the repository where it's hosted, basically kind of downloads the code from there and imports it into your project. So if you're writing something that other developers are going to be importing into their project, you will need to have that hosted somewhere. And then the name of your project will then just be the link to that repository, right? So we have that. One other thing that would be here, whenever you are ready to install an external library to a Go project, in the same folder directory where you have your go.mod, you would type in go.get, and then again, that link to wherever you have that external library hosted. So again, that would just be the words go, get, and then the link. And then it will automatically install it for you. It's basically the exact same thing as npm install for those of you who have used JavaScript before. Let's see. Now on exports, right? So there are certain rules for how we can access variables and functions in a package. If you have something in a package, whether it's a variable or a function, anything else in that same package automatically has access to it, right? Even if that code is in a different file. Now to export something to a different package, you have to capitalize its first letter. And again, another kind of Golang thing that's just kind of weird. In other languages like JavaScript, you would have to like write export specifically. So for this, you just capitalize the first letter. So anything you want to keep private to the package, first letter must be lowercase. Anything you want public, first letter must be uppercase. Try to keep that in mind because that's a very easy mistake to make that I made a lot when I was first starting out. Now for imports, whenever you're importing code, you're going to put the module name / the package name. So again, here we have a project, it's just named example project. So we do that and then / the package. Now, again, if you're using external libraries, the module name here would again be that whole link where you downloaded the library from. So let's say this was some library I found on GitHub. It would be github.com / so on. And then whatever package you want would still come after that. Now, packages can contain their own packages and so on and so forth. And that was actually on the next slide. So I jumped the gun there. If you're calling a function from a package, you have to specify the package before you call that function, right? So let's say I import the math package here. I have to write mathematics first to specify that I'm getting this function from that package, and then I can call it. Now, this does look basically identical to something from a receiver function. So that is something to be aware from. That is something I personally am not a big fan of because it's easy to get them confused. So just make sure you sort that out before you like try to call something like this because you thought it was a struct somewhere. Now, the part that I started talking about a few seconds ago, packages can have their own packages, which can have their own packages and so on and so forth. Whenever you're in a situation like that, if you have any kind of nested package, you need to import all of them, right? So in this example, I have the geometry package, which is inside the math package, which is inside our whole project here. So I need to specify that I'm importing the math package first and then getting the geometry package from that. Now, the good thing is when we actually use our function, we don't have to rewrite all that again. We just write the lowest package wherever our function is, and then we can call it like we did before. And yeah, that's about it for me. So since we are running a little short on time, I'm going to go ahead and give it to Michael for our demo. Again, if you have any questions at all, or there's anything you didn't understand, I will be taking questions afterwards. Yeah, it's the same. All right, guys, so I'm going to try to make this as quick as possible because I know it's already a little bit late. Let me just get on the Zoom real quick and I'll share my screen for you guys. All right. So basically the way this is going to work is you guys are all the unpaid interns at SSD Incorporated, and a software engineer in the kitchen made an API for the cafeteria food, basically. So it's an internal tool that the engineers can go and look at and see what is on the menu for the day and what's available. Let me just get in here and share my screen, and we're going to do. Let me mute. Okay. I got to enable screen sharing. Stop share. Where is it? Oh, here it is. Okay. So now let me come back here, share my screen. I'm just going to share the whole thing. Okay. So this is what we're working with here. We've got 2 files. The last one is the API key for my Google account, so I'm not going to be opening that one. Oh, you can't see it? Oh, do I need to move it over? Okay. There we go. Okay, so we're going to start with main.go here. So basically, just as Jonas described, we've got our main package here, our import statements. Oh yeah, it's too small. Okay. Okay. So we got our main package here. We've got our import statements. And so the items are basically going to be our cafeteria items. And as Jonas said, there's a lot of stuff baked into Go, which is really great because you can literally just, boom, there's a server. So right there, that's your app. All right. So, and then this server is listening on port 3000. So when we run this, we can just go to localhost 3000, and it's going to serve everything from the www/ directory. I'm not a front-end developer, so the front end is like really bad. Literally all it does is show the data. So that takes care of that. JSON response is basically just how we send the data to the front end. It just turns our data into JSON and then sends it. And then this last thing is a handler for when you request data from the front end. This is what's actually going to send it back. So the main piece that we need to look at here is items.go. So this is using the Google API. So there's a Google Sheets that the people in the kitchen are updating every day with the food. So when we're making requests with this bit here, so again, it has the HTTP functionality built right in. Again, so this is just the spreadsheet that I'm using, and then plus the key, which is from the key module, which again, I'm not sharing because that has my Google API key. And then basically the last thing I gotta talk to you about is this unmarshal JSON. Basically, because it gives you the data in the format of a spreadsheet, which looks like this. And you know, the data is in here. Each of these cells has a different name from the Google API. So instead of having to like figure out what the name of each cell is, all this is doing is it's taking the data, saying like, I don't care what it's called. And then it's turning the three items, which I'm going to show you the spreadsheet in a second, into these three guys right here. So the spreadsheet is going to contain the name of the item, the price of it, and whether or not it's available. So I'm going to go ahead and go to the spreadsheet real quick. And for a real type of example, what this could be is like an external API, an internal tool, or maybe your database. Basically, this is the way it works. Okay, so that's basically the walkthrough of the entire system. Now what we're going to do is go ahead and run it. Okay, yeah, so you can also use go run dot if you just have like one package. And you don't have to compile it, which is kind of nice. So now if we open the browser and we go to localhost :3000, so this is pulling from the Google API. And now we've got it displayed here for all of our software engineers who are going to the kitchen. So I need a volunteer for this next part. You just need your laptop and an internet connection, and you need to be on EDU Roam. Any takers? You don't need to know anything. You just have to type something in. Okay, thank you, Brian. So go ahead and open up an internet browser. And again, so this is a file server, so it's available to anyone who is connected to EDU Roam right now. So I'm just going to grab my IP address real quick. And Brian, all you have to do is open up your browser. Type this right here, 10.136.41.165:3000. Let me know when you got that. You're in? Very good, go to it. You see it? Okay, so I need another person to do that. Can anyone else do that? Go ahead, do it. All right, everyone thumbs up when you got it. Now everyone start refreshing your page. Just spam F5. I'll do too. All right, it's gone. So does anyone have any ideas as to why it's gone? Again, we're getting the file still. So my server is not broken. Does anyone have an idea as to why it's gone? I mean, technically we could DDoS it if we were to do it to like an extent of millions. This is like 4 people spamming F5, so it's not really going to do that, but you're on the right track. Yes. So you can only make 1 request per second to the Google API. And when all of us are spamming F5, it's probably like 20 requests per second. So the solution to this is actually a really great feature in Go called Go routines. And it's sort of like threads in other languages, but like way easier. So, like I said, every time someone asks for the items from the front end, this get items handler is being called, and it's calling get items, which if we look, it's making this direct request to the Google API. So every time someone's trying to access it from the front end, we're making a new request to the Google API, which is like, you know, it works for 1 person, but as soon as you get more than 1 person, it stops working. So I wrote this nice little guy here. We'll go ahead and uncomment it. So the ticker is a great built-in function for Go that just goes off of seconds. So basically it basically ticks every 2 seconds. And this ticker.c is just every 2 seconds, it's going to do whatever is in this case here. So every 2 seconds, it's going to go to the Google API, get the data, and it's going to store it for us. So when now all we have to do is get rid of this. And instead of
having to get items manually. It does it for us in the background. We just have to change a couple things. We need to initialize, we need to start this function. And so the way that you declare a go routine is this go func, and it's just going to do whatever is there asynchronously on a thread, on its own thread. So because this is just an infinite loop that's going to keep grabbing this data every 2 seconds. And then the last thing, again, I couldn't import this yet because as Jonas said, you have to use everything you import. So I'm going to go ahead and save this. I'm going to go ahead and reopen command line. Let's end our run here and we'll do it again. Okay. Looks like we're back. All right, so can everyone go back to this IP and spam F5 for me? Let me know if it works. If you have it, you still have it. Okay, so now we're making like millions of requests, not millions, we're making like 20 requests to my server. But imagine 1 million people are using this app. 1 million people are making requests to the server, but I'm only making 0.5 requests to the Google API every second because it's every 2 seconds. So this is just like a quick little demonstration of how you can use the HTTP file server and also Go routines in any project you're working on. So thank you guys. Trevor, do we have any? Yeah. Wait, I think we might have a question in chat. The Google API can handle 1 per second. How about something like Gin? I don't know what Gin is. You're going to have to look at the documentation for that.
I think it's just a web framework.
So yeah, so you would still be making requests to the Google API if you were using something like Gin. So still 1 per second. So the front end, I should say, like it's just jQuery. Like I just wanted to make it as quick as possible. So like it's literally just making requests to the back end. What's up? Why use Go? So it's really great for like making a quick web server for like a project like this. I use it in my internship, and like instead of having to like navigate through an entire framework, it's pretty quick and easy. It's also great for microservices. It's really fast, and it has a lot of that stuff like a web server baked in that you necessarily wouldn't have in other fast languages like C or C++. What's up, Jonas?
Yeah, no, I just want to add on to what you said. Like it's fast. That's the #1 reason. And like also it's kind of the fastest, probably the fastest you can go in a language without having to go to a low-level language like C, C++, or Rust, and dealing with all the crap that comes with working with a language like that.
All right, Trevor, do you have anything else?
Yeah, I'm just gonna read like I'll just restate the announcements. Like, let's see.
You're going to be resharing.
What's this? It's still recording, right? Yeah. So again, Friday at 7 p.m. We're just gonna hang out here in A101. Since SwampHacks isn't in person again, SSD will be in person for that. And then on Saturday, we're gonna do our workshop on GitHub. It's gonna be like an introduction. So if you've seen that in the past, you don't have to show up to this one. It's just gonna be like a repeat of what we've done every semester in the past. That'll be Saturday at 1:15 p.m. Same room. That'll also be through Hopin, which is what they're using for SwampHacks, not Zoom. Tuesday, which will be a week from today, next meeting, we're going to do an advanced Git workshop, which will sort of follow up on that intro to Git workshop. But again, if you've already done the intro to Git workshop from previous semesters, you probably don't need that again. That will be through Zoom because that'll be just a normal SSD meeting and same room, A101. Yep, thanks. All right. There's still some pizza left, so take it, please.